section 3.4, we're looking at exponential and logarithmic equations. We have two more properties of logarithms that we need to look at. And they are the one-to-one properties for exponential and log functions. The first one says, if b to the u equals b to the v, then the powers have to be equal. U equals v. Well, have we already been using that one?
Yes.
Yes, so that's nothing new. The second one says, if you have log base b of u equals log base b of v, then the u and the v have to equal each other. Okay? So let's look at some examples. Example 1. Solve by using powers of the same base. Have we ever already solved equations with the same base? Yes. So which one am I changing? 36. How can I change it? All right, so that's 6 squared to the x plus 1 equals 6 raised to the x plus 6. Now on the 6 squared to the x plus 1, you have a power to a power. So what do we do with the powers? Multiply them. So that's 6 to the 2x plus 2 equals 6 to the x plus 6. The same base raised to different powers. So what do we do with the powers? Set them equal to each other. So 2x plus 2 equals x plus 6. And now we solve. Subtract x from both sides. And we're going to subtract the 2 from both sides. So that leaves us with x equals 4. Let's try another one. On part B, we have 1/4 raised to the x plus 3 equals 1/2 to the 4x. Which one of those do you think I'm changing? Which base? I have to change the 1/4. Because think about the 4. 4 can be written as 2 squared. Right? So we have to be careful. It's the 1/4 that I'm going to be changing. So let's look at it. 1/4 becomes 1/2 squared, right? Can I write it as 1/2 in parentheses squared? Will that be the same thing? Yes, it will. 1/2 squared. And all of that is raised to the x plus 3 power. Equals, on this side we had 1/2 to the 4x. Okay, again. Okay, power to a power, we do what? Multiply. So it's 2 times x plus 3 equals the other exponent, 4x. So multiplying 2x plus 6 equals 4x. Subtract 2x from both sides, so we then have 2x equals 6, therefore x equals 3. X equals 3. Questions? Okay. Example 2. Solve each equation. Support your solution by a second method. Okay, so a second method. So we have 4 to the x equals 13. Can I change it to the same base? No. There's no changing it to the same base. So what do you think you might be able to do? Can I change it to a logarithm? Okay, so let's go with that. So if I change it to a logarithm, then I would have log base what? Log base 4 of what? 13 equals x. Okay, log base 4 of 13 equals x. Can that be solved?
Yes.
Using what from yesterday? The change of base formula. What did the change of base formula say? Good. Log of A divided by log of B. So which one is on top? Log of what?
13.
Log of 13 divided by log of 4 equals x. Now, for the most part, this quiz is probably going to be a non-calculator quiz. So, have we solved for x? Yes, that's our answer. We're not going to simplify it any further. Once you get it to the point where you would go to the calculator to type it in, you're done. As long as you have x equals, and then it's something you can type in, that is as far as we're going to go. Okay? That is an exact answer. When you actually type it into the calculator, what kind of answer are you getting? A decimal, which is an approximation. Okay? Now, it says support by using a second method. So I want to show you a second method of how you could tackle a problem like this and solve it. Okay? And it's using this second property up above. If log base b of u equals log base b of v, then the u and the v have to equal each other. Well, what we have is we have a situation, the 4 to the x equals 13. We have the u and the v equaling each other. So I can go backwards and say, well, it's the log of u equaling the log of v. So basically what I'm doing is I'm going to be taking the logarithm of both sides of this equation. So to do that, we say log of 4 to the x equals log of 13. And we're using that same property from up above. Okay, so if we look at this, log of 4 to the x, what can I do with that piece of it? The x can go where? In the front. So it would be x times log 4 equals log 13. And now if I'm solving for x, what would I do? Divide by log 4. So x equals log 13 divided by log 4. Did we end up with the same answer? Yes. So that is just a totally different way of solving the problem. Okay? Any questions? I don't think so. No, I think we'll just pick the method you like best. Okay? If you can solve it, good. Part B. 3 times e to the 4 minus 3x equals 6. What should I do first? Nope. Nope, before any converting, you have to divide by the 3. You have a number in front, you have to take care of that first. So dividing both sides by 3 gives us e to the 4 minus 3x equals 2. Now we can convert it into a log. And when we convert it into a log, if it's a base of e, which log are we converting it to? Natural log. So natural log of what? Base e of 2 equals 4 minus 3x. Good. Now what do I do? Subtract the 4. So let's put it in front of the natural log. So negative 4 plus natural log of 2 equals negative 3x. And then finally we divide by negative 3. So x equals negative 4 plus natural log of 2 divided by negative 3. Why do you think I put the negative 4 in front of the log? So it doesn't make it look like I'm doing the natural log of 2 minus 4. Okay? I don't want you to then think, oh, well, I can subtract 2 minus 4, because you can't. You're doing the natural log of 2, and that's separate from the minus 4. So if we put the minus 4 in front, that'll stop you from trying to subtract those two numbers. Okay? All right, so that's our answer. Now let's look at the second way that we could solve it. On the second way, we have to divide by the 3 first. So we're in the same spot of e to the 4 minus 3x equals 2. Question?
Wouldn't the 4 be positive? Equalizing negative should be divided by negative.
Either way, you could write it as 4 minus natural log of 2 divided by 3, or you can leave it like this. Either way would be fine. Okay. All right, so the other way, we're at e to the 4 minus 3x equals 2. The other way says you take the log of both sides. So in this case, we're taking the natural log of both sides. So natural log of e to the 4 minus 3x equals the natural log of 2. Now, when you do the natural log of e to the 4 minus 3x, what are you left with? 4 minus 3x, because the natural log and e, they're basically canceling out. So you have 4 minus 3x equals natural log of 2. Subtract the 4. So negative 3x equals negative 4 plus natural log of 2, and then divide by the negative 3. So x equals negative 4 plus natural log 2 divided by negative 3. And that's our second way of solving it. Questions? Okay, so that's the entire lesson, is just solving these equations. Some of them are going to get a little bit more complicated, and I'm going to walk you through those. But what I want you to do now is on your own, using either method, I want you to solve example 3, parts A and B only. You don't have to do C and D. I'm going to walk you through C and D, but right now, A and B. 6 plus 2 log 5x equals 18. So first we do what? Subtract 6. So 2 log of 5x equals 12. Then what? Good. So log of 5x equals 6. 12 divided by 2 gives us 6. Now what? Convert to exponential. What's the base? 10 to the 6th equals 5x. And now? Nope. Divide by 5. And then we're done. You did it right. So x equals 10 to the 6th divided by 5. That's your final answer. You can't do any dividing out because remember PEMDAS says exponents first before you do division. So it's going to be 10 to the 6th before you ever divide by 5. So we leave that as our answer. Okay. Now let's try the next one. What did you do first on the next one? So natural log of 3d equals 5. Now what? Convert to exponential. The base is to the 5th equals 3d. Now divide by 3. You're solving for d. So if we divide by 3, then we have d equals e to the 5th divided by 3. That's your final answer. Okay. Were y'all overthinking?
Yeah, it doesn't look like that.
Okay. Lauren. What other way? Okay, since it's already in log form, we don't take the log again. Okay? Yeah, it's already in log form, so we don't do the log on both sides here because it's already log form. Okay? Say again? Okay. Changing from log to exponential, it's natural log of x equals y. The exponential form is the base of e to the y equals x. So the base of e to the power of 5 equals 3d. No. No. Cannot multiply both sides by e because that e has a power to it. Mm-hmm. Yes. Yes, you can. Okay. All right. So are we good on both of those? All right. Now let's try part C. Let's try part C. Part C is loaded with logarithms. So we're going to have to use some of the properties we learned yesterday to help us solve these. Log base 5 of x equals log base 5 of x plus 6 minus log base 5 of 4. Which side can I simplify a little bit? The right-hand side. Log base 5 of x plus 6 minus log base 5 of 4. How can that be simplified? I can do that division property with the logarithms. So log base 5 of x equals, as a single logarithm, it's log base 5 of x plus 6 over 4. Now if we use the property from above that says you have the log on both sides with the same base, what can we do with what we're taking the log of? Equaling to each other. So x has to equal x plus 6 divided by 4. Now what? Multiply 4 on both sides. So 4x equals x plus 6. Keep going. Minus x, so we have 3x equals 6, and then x equals 2. X equals 2. Good. Questions on that one? Then part D. Log base 4 of x equals log base 4 of 3 plus log base 4 of x minus 2. So it looks like which side can be simplified first? The right-hand side. So log base 4 of x equals log base 4 of what? 3 times x minus 2. And we multiply them because those two logarithms were being added. So multiplying that out, and then x equals 3 times x minus 2. So x equals 3x minus 6. I can subtract the 3x from both sides, so I have negative 2x equals negative 6. So x equals positive 3. X equals 3. Oh, they have to have the same base, period. Has to be the same base. If it's not the same base, can't do anything with it. Okay. Alrighty. Let's flip it over and look at the next one. On example 4, solve each equation. And again, on these, there's two different methods of solving. The first one we're going to solve is natural log of x to the 6th equals 12. So what do you think first? Change to exponential? Okay. So if I'm changing to exponential, what to the what? E to the 12th equals x to the 6th. Now, did I want x to the 6th? No. So, what do I do? No. Don't flip anything. Think of it if it was x squared. What would you do with x squared? You'd square root it. But it's x to the 6th, so I'm 6th rooting both sides. Okay? Does that make sense? Good. So the 6th root of both sides. So I have x equals. Now let's look at that. The 6th root of e to the 12th. Now rewrite that with a rational exponent. So that would be e to the 12 over 6. And reduce it. E squared equals x. There it is. That's our answer. That is awesome, isn't it? Math is awesome. Yeah? No? All right. Now, I said there's another way of solving it. There's another method. Okay? So let's look and see what that other method might be. The other method is using one of our properties from yesterday. So which property do you think that would have been? The what? Put what in front? The exponent goes in front of the logarithm. So we would have 6 natural log of x equals 12. Then what? Divide by 6. So natural log of x equals 2. And then what? Now, Dwayne said it, exponential. So what to the what? E to the second equals, and voila, we have the same answer. Okay? Yes? No. No. Because I'm taking the natural log of x to the 6th. I can't just introduce an extra natural log to the problem. I can only take the log of both sides when it's in an exponential form. Okay? Lauren?
So unlike the other one, so like if you just number that's either one or the one. It's like on the other one.
Yes.
That it's been lost.
Right. So back on the other, let's see, would either of these work there?
It was A. But you, I think putting a lot of
We'll have to look and see what you were going to try to do. Okay? All right, so let's try another. Part B. 3 times log of x to the 4th equals 2. What first? Divide by 3. So log of x to the 4th equals 2/3. Then what? Change to exponential. What's my base? So 10 to the what? 10 to the 2/3 equals what? X to the 4th. Do I want x to the 4th? Nope. So what would I do? 4th root of both sides. Okay, so x equals 10 to the 2/3 over 4, which becomes what? 2/12. Good. Because the 4 goes on the denominator with the 3. 3 times 4 is 12, so that's 2/12, which reduces down to 1/6. So that's 10 to the 1/6 power. And that's our answer. Okay. Now, just like the other, I said there's another method. What do you think the other method's going to be in this case? Excellent. We're going to move that 3 to the exponent. So when that 3 gets moved to the exponent, it's times the 4 that's already there. So then you have log of x to the 12th equals 2. Now we change to exponential. So the base of 10 to the 2nd equals x to the 12th. And then what? 12th root of both sides. And when we do the 12th root of 10 squared, what does that give us? 10 to the 2/12, which reduces to 10 to the 1/6. Okay, questions? Michaela? Yes, you can. Absolutely. So did you hear what she just said? Instead, what she did, instead of bring the 3 up, she brought the 4 down. So when you bring the 4 down, you have 4 times 3 is 12. Divide both sides by 12. So 2 divided by 12 is the 1/6. There you have your 10 to the 1/6 equals x. So that works too. Perfect. Okay. Other questions? Okay, guided practice, part C and D. Go for it. So on that first step, divide by 2. So e to the 3x equals 8. Then from there, 2 different methods of solving. You can change to logarithmic form. So natural log of 8 equals 3x. Divide by 3, we get x equals natural log of 8 divided by 3. Or, at the step of e to the 3x equals 8, you can take the natural log of both sides. We can do that because it was in exponential form. Natural log of e to the 3x is 3x equals natural log of 8. Divide by 3, we get the same answer. On the other, we need to subtract 4 from both sides. So natural log of x squared equals 12. I could change it to exponential form. So e to the 12th equals x squared. Square root both sides. And x equals e to the 12 divided by 2 power, which is x equals e to the 6th. Or the other method, we're at natural log of x squared equals 12. I could bring the power in front. So 2 times natural log of x equals 12. Divide by 2. So natural log of x equals 6. And then e to the 6 equals x. You only have to be able to do one method and get me the correct answer. You don't have to do both. But I wanted to show you both because some of you probably did one method and some probably did the other. Okay? Any questions over any of that? All right. Now we're ready for the last two examples. Last two examples. They're a little bit different. Okay? A little bit more complicated. Log of 3x minus 4 equals 1 plus log of 2x plus 3. What do you think is the one thing that causes this to be more complicated? The plus, or the, yeah, that 1 plus. That tiny little plus 1 causes everything to be a little different. In this case, you need to get anything with a logarithm on one side of the equation. Okay? So if it has a log, put it on one side. If it doesn't have a log, so that plus 1 will be on one side by itself. So I need to move the log of 2x plus 3 and subtract it over. So we're going to have log of 3x minus 4 minus the log of 2x plus 3. And that will equal that 1, the one that was already there. Okay, so did everybody follow that? All I did was take that one log and subtracted it to the other side. Now that we have it on the other side, are those two logarithms with the same base? Yes, so what can I do with it? Okay, so I'm dividing, but it's just a single logarithm out front. So a single log out front. What's on top? Divided by what's on bottom? 2x plus 3. And that equals what? 1. Okay. At this point, we need to convert it to exponential. So what's our base? So 10 to the first equals 3x minus 4 over 2x plus 3. Now what do you think? Multiply 2x plus 3 on both sides. So 10 times 2x plus 3, I need to distribute. So 10 times 2x, 20x. 10 times 3 plus 30 equals 3x minus 4. Subtract 3x, so we get 17x. Subtract the 30. Negative 4 minus 30 is? Yep, negative 34. Divide both sides by 17, and we get x equals negative 2. Now, when you get a negative answer, this is where we have to be careful. You can never take the log of a negative number. Okay? So if I take negative 2 and I plug it in for x, 3 times negative 2, negative 6 minus 4, log of negative 10. Doesn't exist. Can't be done. So that one, no solution. So always be careful of that, especially when you get a negative number for an answer. Check it to make sure. Okay. The other one, log base 12 of 12x minus 2 equals negative log base 12 of x minus 1. All right. What I want to do here is, I don't like that negative log on the right-hand side, so I'm going to move it over to the other side by adding. And then that negative 2, I'm going to add it over to the right side. So we'll have log base 12 of 12x plus log base 12 of x minus 1 equals positive 2. On the left-hand side with those two logarithms, what can I do with those? I can multiply them and turn it into a single logarithm. So log base 12 of 12x times x minus 1. And that equals 2. So let's go ahead and multiply that out. So log base 12 of 12x times x, 12x times negative 1 is minus 12x. And that equals 2. Now convert to exponential. So what to the what? 12 squared equals what? 12x squared minus 12x. Okay, let's move the 12 squared to the other side. So 0 equals 12x squared minus 12x minus, and what is that 12 squared? 144. Does that have a common factor? Yes, 12 is a common factor, so I'm going to pull it out. So that's 12 times x squared minus x minus 12. Can that quadratic be factored? To what? X plus 3, x minus 4. So what are my answers? X equals negative 3, x equals positive 4. Now go back up and check. Will negative 3 work? No, that's going to cause you to take the log of a negative number. Does 4 work? Yes, 4 works. So that's your answer. Questions? All right.